Hello, welcome to our channel for rprogramming. In this video, we will show how to calculate type 1 and type 2 errors in hypothesis testing using rprogramming. So we know in hypothesis testing in statistics, you will commit a so-called type 1 error when rejection of the null hypothesis, but when actually it is true. So rejection of the null hypothesis at 0 when it is true is called a type 1 error, or this is alpha. For instance, in a sample of new vaccine, they show if you get more than 8 positive from a 20 sample, then you will reject the H0 in favor of H1. H0 here, for example, is 0.25 for binomial process, with the 0.25 is for the success rate in each trial. And for 20 sample, you get 8 positive, more than 8 positive. Then you will usually reject H0. But actually H0 may be true, because if H0 is true, you can also get the possibility of 8 positive in a sample of 20. But if we set the critical line with 8, so you get 8 positive, then you reject H0. So in this case, you commit a type 1 error. And on the other side, you may do not reject the null hypothesis, and when actually it is false. So this error is called type 2 error, is beta. For example, in a hypothesis testing, H0 is 0.25 for a binomial success rate, but actually H1, or say alternative hypothesis, P, the probability is 0.50 in each trial. Actually, if H1 is true, you can also get 8 or fewer positive in a 20 sample. So in this case, you may not reject H0, but actually H1 is true. So this kind of error is called non-rejection of the null hypothesis, where actually it is false. So this is type 2 error. So next we will show examples for calculating type 1 and type 2 error in rprogramming. So this example is what we have said. H0 is the probability equals 0.25 in a binomial success rate, binomial trial, and H1 is the probability of 0.5. And we want to test hypothesis H0 is true, or maybe rejection of H0. And we get 8 positive. Here, more than 8 positive in a sample 20. Then we will reject. So 8 is the critical line, critical limit. If more than 8 positive, then you will reject H0. So here, the alpha, or say type 1 error, is the probability x, a positive number larger than 8. But when actually the null hypothesis 0.25 is true. So we want to calculate this probability for type 1 error. And in R, for the binomial distribution, the function p binom is used to find the cumulative probability of a data following binomial distribution to a given value. So which means p binom will calculate the probability of x less than or equal to k in a binomial distribution. So the syntax is p binom, k, n is the sample size, and k is a positive number in this sample, and p is success rate for each trial. So it's quite simple. We want to calculate type 1 error because P by num is the cumulative probability up to 8, right? In a sample of 20. So we just use 1 to minus this probability, then we can get type 1 error. Just to learn. So in this case, the type 1 error is 0.04. And the type 2 error is when actually H1 is true. H1 is the probability is 0.5 is true. And we do not reject H0 because we get the positive cases less than 8 here in a sample of 20. So we can also use the P by num. P by num 8 size 20 probability here 0.5. So we do not use 1 minus because this will calculate the probability of from 0 to 8 positive in a 20 sample. So type 2 error just equal to P by num 8 size 20 and probability equals 0.5. So in this example, the beta or type 2 error is about 0.25. It's quite large. So about 25% of the probability, you will not reject the H0, and actually H0 is false. Thanks for watching.